All right, we're looking at Inquiry Lab Area of Trapezoids, which starts on page 681. And this is what the pages look like. The question for this section is, how can you use the area of a parallelogram to find the area of a corresponding trapezoid? And the story goes, Lizette is building a garden in the shape of a trapezoid. The garden is 6 feet wide in the back and 8 feet wide in the front and 5 feet from back to front. She wants to find the area of the garden. So it says, oops, sorry, get rid of all that. There we go. It says find the area of a trapezoid by drawing the related parallelogram. So for number 1, it says trace the trapezoid below on grid paper and label the height H and label the bases B1 and B sub 2. Whenever we have the numbers on the bottom, like they have in these two for B1, B2, we call that B sub 1 and B sub 2. All right, so a trapezoid has two bases, B1 and B2, and then the height H of a trapezoid is the perpendicular distance between the bases. So, because there's a lot of different shapes for a trapezoid, but we're talking about the height being from the distance from one base to the other, and it's perpendicular, which that's the same as what we've been working with triangles and parallelograms. So you should be used to knowing that by now. All right, so we have two bases. Sometimes they have big base and little base. Sometimes that's how we say it because one base is always bigger than the other when it's talking about a trapezoid. So there's a lot of different ways that we might say that, but B sub 1 and B sub 2, all right, are how we show it in the formula. All right, so the shorter base B1 represents the garden width of, and it had said that garden was 6 feet wide, okay? So that would be our 6 feet. Then our longer base B2 represents the garden width of, and that's going to be our 10 feet wide because that's our bigger one, 10 feet. And then the height represents the garden dimension of, and it told us that it was 5 feet from the back to the front. So 5 feet. All right, so it says number 2, cut out another trapezoid that is identical to the one from step 1. Now again, you could be doing this on a separate grid paper if you'd like to do this and like have that hands-on experience, but we can also just visualize with what we're doing here with the pictures. So it says tape the trapezoids together as shown. So we've got two identical trapezoids, and you see that they put one upside down and one right side up, and they put them on top of each other side by side. So if you notice, the shape that it makes is, this is familiar I hope, it's a parallelogram. All right, so finding the area of the parallelogram would be base times height, right? And they're saying that if we want to know what it is for just a trapezoid, that we can take that area formula for a parallelogram, which is base times height, and we're going to divide it by 2. And that way we can find the area of each trapezoid. All right, so let's try that out. So if we've got B2 here, which was 10, and we have B1 right here, which was 6, then what is the base of our parallelogram? 16. And then our height doesn't change, even though we have them side by side, that's still 5. So if we were to take our base, area equals base times height, remember OSS, original is our starting point, area equals base times height for a parallelogram, we would have 16 times 5, and that would tell us what it would be for this whole shape right here. Okay, the whole parallelogram. So that's 80 feet squared. I'm trying to look at my units while I talk at the same time. All right, so 80 feet squared, but I only need half of it because I am just talking about one of the trapezoids, not the parallelogram. I just want to know what the area is for this shape right here, not the entire thing. So I'm going to take this and divide it by 2 because there are 2 trapezoids in this picture that make this parallelogram. So if I divide that by 2, I get the area is 40 feet squared or 40 square feet. So I really like this demonstration. I've actually never seen this in a book before, where they take the trapezoids and they put them inverted next to each other and stuck together, and they make the parallelogram. I think this is an amazingly great way for you guys to see how this formula that I'm about to give you for the next section works. And see that we're taking the B2 and the B1 and we're adding them together for this parallelogram. We're taking the height of this trapezoid and parallelogram, and then we're going to divide it by 2, since this represents 2 trapezoids together. Okay? So I just think that's great that they've outlined that for you. So let's look at activity number 2. It says discover the formula for the area of a trapezoid. Step 1. What figure is formed by the 2 trapezoids in activity 1? Well, that was our parallelogram. All right, so parallelogram. And then it says write an addition expression to represent the length of the base of the entire figure. Remember that it was our, and it doesn't matter which way we do this, it was our big base plus our little base, and that makes the base of the parallelogram. So it's our B1 and our B2 added together. So B1 plus B2. And remember that we have these little sub, we put them on the bottom there. So B1 plus B2 makes the base of a parallelogram. So write the formula of the area of the parallelogram using B1, B2, and H. So if we're finding the area of the parallelogram and we're using B1 and B2, then we're going to do, it used to be area equals base times height. Well, the base in this case is going to be base sub 1 plus base sub 2, and then we're going to multiply that times the height. So here's another way that we could say the area formula for a parallelogram. If we know that there's B1 and B2 here, then we multiply those two by the height. Now it says, how does the area of each trapezoid compare to the area of the parallelogram? Well, look at this. We've got one here, and then the identical one this way. And so hopefully you see that the area of a trapezoid in this picture, when we're talking about an entire trapezoid, or sorry, parallelogram, that the area of the trapezoid is 1/2 of the area of the parallelogram. That says gram. All right. Then it says to write a formula for the area A of each trapezoid using B1, B2, and H. All right, so again, if we were using B1 and B2, this is the area of a parallelogram. And then we know that the area of a trapezoid is 1/2 of the area of a parallelogram. So if I were to write that out, I would say 1/2 of, okay, first of all, area of our trapezoid is going to be 1/2 of base sub 1 plus base sub 2 times H. Because it's half of this. If I'm talking about this parallelogram, my trapezoids, if I want to know the area of just my trapezoid, it's just 1/2 of that. All right, so another way to find the area of a trapezoid is to deconstruct it to determine which figures form the trapezoid. So it says find the area of the trapezoids shown below. So now they're saying, okay, what if we took this little wing and we put it over here and we made it like this? Then you'd see that the new shape would be a rectangle. And we have that this was, let's see if this will be easy for me to show you with different colors maybe. This 3 inches is now added down here to the 6 inches that we already had here. So the total length of the side of the rectangle, if I were to make this into a rectangle, would be this plus this. So that's going to be 9 inches. Okay? And the height is still the 5 inches. So if I were to find the area of this rectangle, because I'm taking my two little wings and I'm moving and combining them to make it into a rectangle, I would do base times height at this point, which would be 9 times 5. Okay, so the area of the rectangle would be 9 times 5, which is 45 inches squared. Okay, hold on a second. I just realized that maybe... I see what they were trying to do. All right, well, let's not do that then. And I'm not going to erase this video. It's 10.5 minutes in. Instead, let's just erase what we had. And let me start over by saying, and if you were using pen or marker, then, they want us to find the area of this rectangle and then add the area of these two triangles. Okay, I got you now. So the area of this triangle is 1/2 times base times height, which is 1/2 of 3 times 5, which would be 15. 1/2 of 15 is 7.5. So we would say, okay, this is 7.5. There we go. And we have 2 of them, so that's going to be 15 square inches altogether. The area of our rectangle here is going to be the 6 by the 5, which would be 30 square inches. And so if we were to add them together, we've got our 30 square inches plus our two 7.5s for our two triangles, and that would be a total of 45 square inches, which if you rewind back to what I was just doing where I was taking this and moving it over to here, my area was actually 45 square inches. So I was just showing another way of doing it. You're welcome. All right. So again, you can rewind and see how I did that one, because I don't know if they're going to, nope, they're not going to give us another activity. How about I just real quick, and I know you guys have more videos to watch. I'm just going to really quick say, okay, so here's what I was talking about before. All right, this triangle here could be flip-flopped and added over here to this side of this trapezoid. So then this is gone because it's over here now. And my entire shape is now, let me get a different color, is now a rectangle. And so if I use area equals base times height of this rectangle, I would find the area of this trapezoid. All right, so just putting that out there. But that only works depending on what type of trapezoid we have, because there are lots of different trapezoids out there, and they will not all be this easy. All right. So if you have any questions, I'll see you in school. All right. Bye-bye.